Great, question 4. The diagram shows a moving tractor. The forward force from the engine exactly balances the resisting forces on the tractor. So that could be friction, air resistance, any sort of drag forces. So what we've got is we've got a forward force, and that is exactly equal to the backwards force. So again, let's just give it some numbers. Let's say that's 100 newtons. Let's say that's 100 newtons. We would have 100 in one direction minus 100 in the other direction, which would give us overall force of 0 newtons. Describe the motion. If there's 0 newtons of force, it will be a constant speed. It did say it was a moving tractor, so it's already moving, so it will just keep moving at the same speed. The tractor comes to a drier part of the field where the resisting forces are less. If the forward force in the engine is unchanged, if at all, will the motion of the tractor be affected? So we can take this backward force, we can change it. I'll get rid of that as well. So we get rid of the backward force. And so let's say that they are now less. So let's say that they've gone to 80 newtons. So we'd have 100 minus 80, which would give us 20 newtons acting in the direction of the largest force, so 20 newtons that way. So it would accelerate, and it would accelerate forward. So how will the motion? It will accelerate in the forward direction. It's worth 3 marks, this one, so we're going to have to add a little bit more of that. So it will accelerate in the forward direction to reach a higher speed. But actually it's worth 3 marks for the motion of the tractor and this, so yeah, that's probably enough. Right, 2 pupils are given the task of finding out how fast a tractor moves across a field. As the tractor starts a straight run across the field, the pupils time how long it takes to pass a series of posts where there are 40 meters apart. The results obtained are shown in the table below. So we have to draw a graph. Draw a graph of the distance travelled against the time taken using the axis on the graph below. Label your line line A. Alright, so we've got distance on one side, and then at the bottom we have got time. Let's see if I can fit that onto one screen. There we go. Alright, so we are going to have to plot our point. So when there's 0 distance, 0 time. So 0 distance is at the bottom with 0 time. So put a plot at 0 and 0. The next one is 40 and 8. So 40 meters and 8 seconds. Let's have a look at this scale. So we've got 10 seconds here. Let's see how many squares it is. It looks more than 10 to me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's, there's 10 squares there. 12, 13, 14, 15. So we've got a scale. So it's always good to know your scale. So we have 20 squares is equal to 10 seconds. So what is 1 square equal? Well, if we divide that by 20, we have to do the same on that side. So 10 divided by 20. Remember, use your calculator, even if you think it's easy. Even if your brain is screaming at you, I know the answer. Check it, because it's an exam and there's no room for mistakes. So each square is worth 0.5 seconds. So that's a classic error they would try and throw at you. They would try and get you to plot it on thinking each square is worth 1. So we need to find a time of 8 and a distance of 40. Okay, well the 40 is labelled for us, so the 40 is along this line here. So we just need to find our 8. Now the 8 is going to be, that's going to be our 9, that's going to be our 8 there, because it's 8 squared being 0.5, that's 2 squares, 4 squares back. So 8, and follow it up, you would put your ruler along the line, and you would find that. Okay, we're going to take that away. So 8 and 40. The next one is 80 and 16. Okay, so we need 16 along here. So again, each square it's, two squares. So that'll be 11, 12, 13, 14, 15, 16 should be there, just check. 16, 17, 18, 19, 20, yeah, that works. So that is 16, and we want that 16 to go with 80. So again, we would get our ruler, we would place it on, and we'll draw that line up, and we can see that it's there. I'm going to get rid of that to make it less confusing. So 16 and 80. 24 and 120. So 24. So 21, 22, 23. That should be our 24. And 120. Sorry, 120. So again, draw that line. Especially now that we're starting to get further away, our ruler is going to be our friend here. There. What I'm going to do is I'll just rub out the line as we do it. Alright, now I'm not happy with that point because it's slightly off the line. So you're allowed half a square tolerance, but I think we could be a bit more accurate than that. So I really want to look, see, it's just off. There we go. Alright, that's the beauty of having an iPad. For you, plot in pencil, and you can do that same thing. Alright, where are we up to? 32 and 160. 32 and 160. So that's 31. 32 should be here. 32. Draw that line up to the 160. So put your ruler on the 32. And that wasn't very good. Straight line. Should be there. And that should go to our 160 point. And then we rub out that. And our last one is 40 and 200. So 40, dead easy. Actually, that one, because that was done for us. 40 and 200. So there, again, not happy with that. Let's rub that out. And let's put that on again. 40 and 200. Right on that point there. So we have to draw our line now. And let's have a look. We should have, this looks like it's a directly proportional line, but I'll use a different colour. But we can see that if I just put oh dear, keep dropping my iPad. Let's line this up. You can see that perfectly straight line goes through every single point. So that is our line. And we have to label it line A. So let's do that. So it's line A, and we can see, I mean, you don't need to write this on, but this is directly proportional because it is a straight line, linear relationship that goes through the origin. So it's directly proportional. It now wants us to calculate the speed of the tractor. So in order to calculate the speed of anything, you have to just find out the gradient of the line on a distance time graph. So the gradient of the line is going to be the change in y divided by your change in x. So we do the biggest right angle triangle possible, which is here and here. That is our biggest right angle triangle that we can do. So we can see that the x-axis goes from 0 to 40. So we've got a change. So your change in x is 40 seconds. And our change in y goes from 0 to 200. So our change in y is 200 meters. So we want to do change in y. So it's 200 divided by our change in x. 200 divided by 40, which is going to give us 200 divided by 40, which is going to give us 5. So it equals 5 Now, Class 8, to get that third mark, it wants you to give the speed, and it hasn't given us any units here, so it's 5 meters per second, because we divided the meters by the seconds. In another wetter field, there is more resistance to the movement of the tractor. It now travels at 4 meters per second. All right, so that's actually giving you a bit of a hint here, in that your answer to part B should be higher than 4, because if your answer is lower than 4, then this sentence wouldn't make any sense. So there's more resistance now, so therefore the tractor's going to slow down, which it has, to 4 meters per second. Calculate the time needed to travel 200 meters. So what have we got? We have got a speed. I'll write this on this page. So we've got it here. So let's just list our values. So we've got speed, which is 400. Oh no, it isn't. Sorry, it's 4 meters per second. And it wants the time. And we have got a distance, which is 200. Hopefully you're all screaming in your head now, speed equals distance divided by time. But let's just go to our data sheet. Again, it's the exam, so let's check. So we're looking for something that's got speed in it. Or I suppose it could be velocity, because velocity is speed but in a direction. Let's have a look. I don't find it. Aha, there we go. So it's written in a slightly different format. So distance travelled is speed times time. So it wants the time. So FIFA, the formula, distance equals speed multiplied by time. All right, input those values in there. So the distance is 200 equals a speed, which is 4, times by the time, which we don't know. So let's do the fine tuning of this. So in order to leave time on its own, we do the inverse function. So it's been times by 4, so we're going to divide by 4. That will cancel the 4s, leaving time on its own. We've got to do the same to this side, so divide by 4. So we will end up with 200 divided by 4 is equal to T. And we'll figure out that answer. Let's just calculate again. 200 divided by 4 gives us 50. Okay, and if I was to write my answer here, 50 seconds, it's not very obvious to the examiner, so we want to get it on that line. So let's write 50 seconds, put it on that line, and let's underline it so that they can see that that's our answer. On the graph in part B, draw a line to represent the motion of the tractor across the second field. Label this line B. So back to the graph, and we need another line on there to represent the motion of the tractor across the second field. Label this B. So the line is going to have a lower gradient because the tractor is traveling slower. But we know we've got a point here. So we've got 200 meters and 50 seconds. So we can't do 50 seconds, but we can do 200 meters. So let's take some things off this graph so I can get it back to where we want it to be. Sorry, we should leave line A on there because that's what we were asked to actually label. So I'm going to take this off and we'll leave it like that. So that's what yours should look like in the exam. So we want a gradient where the speed is 4 meters per second. So we want a gradient where the speed is 4 meters per second. So how could we achieve that with our 40 meters? So if we know that, so speed equals distance divided by time. If we know that the speed is 4, how far will that cover in 40 seconds? So So let's rearrange this and fine tune this. So we're going to multiply this side by 40 and that side by 40 to cancel that 40, which will leave us with 4 times 40 is equal to the distance travelled if the speed is 4 meters per second. So 4 times 40 again, no matter how easy, do a calculator on a calculator. So the distance is equal to 160 meters, and that's in 40 seconds. 160 meters in 40 seconds. So that's our plot. And we know it starts at 0, 0. So we just need to draw that one line. So I will do this one in blue to make it a bit different. So we've got 40 seconds here, and we're going to do 160 meters. So we'll draw a line up to 160. This is there. Put it on that point. Make sure it's on there. Yes, it is. Get rid of that line. And then we're just going to connect that from the origin. That's I've made a curve. I did not mean to make a curve. I meant to have a straight line. Try again. Okay, there we go. Straight line. So that's our directly proportional line, and that is line B. And we can just check that that gradient gives us 4 meters per second. So it should do. So we've got our changing y divided by our change in x. So our change in y is 40, and our change in x is, sorry, no it's not. Our change in y is 160. 160 divided by 40, and we just need to check that that is going to give us our gradient, which is our speed of 4 meters per second. So let's just do that. So 160 over 40 gives us 4. So yeah, that line is correct, and that's got the gradient that we're looking for. Okay, on a road, a tractor accelerates. Just mention with this point as well. This is a classic example here where there's some marks, but it doesn't look like there's anything to do. All right, but there is a mark there. So those questions people miss out all the time. Make sure you read it carefully. Make sure you look for the marks and see that it wants you to do this on the graph. On a road, the tractor accelerates from rest to 6 meters per second in 15 seconds. Calculate the acceleration. So we want acceleration. So we're going to look for a formula that contains acceleration. We have got rest, 6 meters per second and 15 seconds. So rest is 0 meters per second, and that would be your initial velocity. That 6 meters per second is our final velocity, and the 15 seconds is obviously our time, and it's the right units because it's in seconds, and we want acceleration. So we've got acceleration, and we've got an initial and final velocity, and we've got a time. Let's have a look at the formula that we need. Get rid of the one I used earlier. So we're looking for acceleration, and I'll highlight any time we see acceleration. Nothing on there. Okay, we've got acceleration, change in velocity divided by time. Yep, we've got all of those things. So acceleration is equal to our change in velocity divided by the time taken. So we'll use FIFA again. Acceleration is equal to our change in velocity divided by time taken. We will input that data. So we're trying to find acceleration. Our change in velocity is going from 0 to 6, so that is 6, change of 6. You can show that 6 minus 0 equals 6, so our change in v is equal to 6 meters per second, divided by the time taken, which was 15 seconds. So we don't need to rearrange. Acceleration is our subject already, so we just get our answer. 6 divided by 15. 6 over 15 gives us 0.4. 6 divided by 15, just to check. Yeah, 0.4. So it's 0.4. So our acceleration is 0.4 meters per second squared. Make sure, even though because I've written it here, okay, we need to make sure it goes in that box. All right, that's the end of that question. That's the end of question 4.